This week on Maker Update, a 3D chicken printer, AI arms, robot heads, a motion-controlled garbage hole, and an RC furniture dolly. Hey, I'm Donald Bell, and welcome back to another Maker Update where we bring you the latest projects and tips from the Maker community. I hope you're doing well. We have another great show for you. Let's get started with the project of the week. On his YouTube channel, Simon Sorensen from RCLifeOn shows how he made this electronically controlled incubator for hatching his own chickens. The end result kind of looks like an enclosed 3D printer, but when you think about it, it's actually solving some of the same challenges as a 3D printer in terms of temperature regulation. But unlike a 3D printer, you actually want to invite in a lot of humidity. In fact, keeping the humidity level right around 50% seems to be the most complicated aspect of the design. Not only do you need a way to regularly introduce water into the system, but you also need a method for releasing moisture if the humidity gets too high. Simon's design uses a funnel for adding water when needed. To let moisture out, he's using a small PC fan with a 3D printed housing and a flap that naturally closes when the fan is off. In fact, it's worth pointing out that all of the orange-colored elements on this design are 3D printed. From the handle to the hinges, the cable covers, the water funnel, even the tray holding the eggs and the mount for the motor that occasionally rolls them. Now, when it comes to setting and managing all the different electronic routines in this project, I imagine some of you would go for a single, custom-programmed microcontroller with different sensors and motor drivers attached. But for this initial design, I can absolutely relate to Simon's decision to use a group of off-the-shelf dedicated modules for maintaining the different functions. There is an inexpensive module for setting and maintaining the heat with its own thermistor and a relay for turning the heat bed on and off. There's a dedicated speed control module for the mechanism that turns the eggs a few times a week. This module includes a delay and timer function so that the eggs aren't constantly being rolled. And finally, there's a humidity regulator module where you can set your desired percentage. It includes a humidity sensor along with an ultrasonic mister and a connection for an exhaust fan. All working together with some luck and patience and some fertilized eggs, and you've got baby chickens. What a cool project. It's a great video too, and you can find a link to it down in the description. Now for some news. There's a new, inexpensive, open source robot arm in town called the SO101. The arm was developed in a collaboration between Robot Studio and the AI platform Hugging Face. It's an easier to assemble version of the SH100 arm released last year. The mostly 3D printed design can be built for as little as $130 in components. You can find a link to the GitHub published files, code, and bill of materials using the link in the description. What makes the arm so remarkable, aside from being inexpensive to reproduce, is how easily it can be trained to perform different custom actions. Not only can you put it into a leader mode where you can physically move the arm to produce the action you want, but there's a sophisticated AI system behind it that learns and adapts. It looks like a lot of fun to play with, and with this level of documentation and support, it's bound to be the go-to solution now for any hobbyist robot arm projects. Keep an eye on this one. Speaking of robots, arms are great, but who's working on the face? Well, animatronic wizard Will Cogley is making some great strides. He's released a new batch of files for his robot head design. It includes servo-actuated eyes and a mouth, but just as important for realism, there are dozens of smaller movements around the mouth and eyes to make it more expressive, adding up to a total of 21 servos. Oddly, one of the main legal roadblocks for publicly releasing the final design are some possible patents around how silicone skin attaches to the frame. For a simpler, less terrifying project, check out this desktop motion-controlled wastebasket by The Wrench. The cool feature here is the camera iris style opening driven by a single servo. An ultrasonic rangefinder above the opening detects nearby movement and triggers the servo. An Arduino Nano runs the code. Everything else is 3D printed. And on Hackaday, Austin Allen shows how he made this motorized, remote-controlled furniture dolly. This seems like one of those projects that was born from a silly idea and then snowballed into an ornate triumph of engineering. In the end, this humble furniture dolly is transformed into a brushless motorized go-kart with its own custom hardware remote, plus a Bluetooth interface for phone control. And of course, there's some LED lights on the side for nighttime visibility. Now for some tips and tools. On the Maker's Muse channel, Angus offers up a look at the Scotch Yoke. This is a mechanism that dates back to the Industrial Revolution and provides a relatively simple way to convert rotary motion into reciprocating linear motion. That said, it's rarely used today, it's interesting to learn why, and it doesn't mean it's not worth considering for use in your next project. On the Robonyx channel, there's a useful and entertaining beginner's guide to surface mount soldering. There are 3 main techniques covered here: soldering iron, hot air, and hot plate. He covers a lot of ground in just 15 minutes, plus there's a bunch of great tips throughout the video, including using Kapton tape for heat shielding, using plastic tweezers to hold components, inspecting work with a magnifying loupe, and a good solder paste you can keep on your workbench. And over on Adafruit, the Ruiz brothers have a guide on how to make your own custom 3D printed figurines using AI tools. The workflow uses a combination of ChatGPT for the 2D reference, Masterpiece X to turn it into a 3D model, and Blender to polish up the results. For this week's DigiKey Spotlight, check out a recent video from their product discovery channel unboxing the Harmony XB5R wireless and batteryless push-button switches from Schneider Electric. Now this is a high-end industrial automation component. It's nothing you or I are likely to buy, but it demonstrates a fascinating concept where a wireless button can transmit on and off messages to a receiver without needing any batteries to recharge or replace. The trick is that the buttons in the transmitter convert the mechanical energy of the physical button press into just enough electrical energy to signal the receiver. Check it out. All right, and that does it for this week's show. Be sure to subscribe, leave a thumbs up, leave a comment. Thanks to Cria Ciencia for the use of their lab. They're a wonderful resource for childhood science education in Barcelona, and I'll leave a link where you can learn more down in the description. A big thanks as always to DigiKey for making this show possible, and thank you for watching. I'll see you soon.